Every single day, you navigate the web. You type addresses, click links, and probably, almost unconsciously, notice HTTP or HTTPS at the beginning of a URL. We've all done it. It's become so ingrained, so automatic, that we rarely stop to consider what those prefixes actually signify.
That's true.
Or perhaps even more profoundly, how the intricate web pages you see, with all their dynamic content and functionality, truly make that journey from an initial concept on someone's computer to a globally accessible resource, instantly available right there on your screen.
It's quite a journey.
This deep dive is about pulling back that curtain. We're going beyond the surface definitions to explore the fundamental architecture and the communication protocols that govern virtually every interaction you have online.
Yeah, the rules of the road, so to speak.
Exactly. Our mission today is to transform those seemingly small, often ignored details into powerful insights, giving you a nuanced, clearer understanding of the Internet's sophisticated inner workings. And, crucially, what that deeper understanding means for your digital security, your online experience, and maybe even your perspective on web development. Okay, let's unpack this.
It's an excellent point. We interact with this technology constantly, yet the underlying mechanisms often remain invisible.
Right.
But truly, understanding these foundational principles is like having a new lens through which to view the entire digital landscape. It demystifies so much of what happens every time you send an email, stream a video, or simply refresh a web page.
Absolutely. So let's start with those ubiquitous prefixes, HTTP or HTTPS. We see them everywhere. Beyond just being a part of a web address, what are they truly communicating to our browsers? And what's the fundamental difference in how they sort of orchestrate the dance between your computer and a web server?
What's truly fascinating here is how these protocols dictate the very language of the web. They're not just decorative. They're foundational communication protocols.
Okay.
When your browser sees HTTP or HTTPS, it immediately knows which established set of rules and procedures to follow to request and receive data from a web server.
Like a specific dialect.
Kind of, yeah. Think of HTTP as the original pioneering grammar for how browsers and servers speak. It stands for Hypertext Transfer Protocol, a protocol designed for fetching hypertext documents, which are essentially web pages.
Right, the basic building blocks.
Exactly. The standard established since the early days of the web.
And when you say grammar, you're really talking about a structured way of asking for and receiving information. Can you elaborate a bit on the core principles of HTTP that made it so, I guess, revolutionary back then?
Certainly. HTTP's brilliance initially lay in its simplicity and its stateless nature.
Stateless. What does that mean exactly?
It means when your browser makes an HTTP request, say, asking for a specific web page, that request is treated as a completely independent transaction.
Right.
The server processes it, sends back the requested data, and then essentially forgets about that interaction.
No memory.
Right. It doesn't inherently maintain any memory or state of previous requests from the same user. This design choice made HTTP incredibly efficient for serving static documents quickly, which was perfect for the web's early role as a distributed information system.
Makes sense.
Your browser gets a page, the server sends it, and that's that. This request-response cycle is, the heartbeat of the web.
That statelessness sounds incredibly efficient for simple information retrieval. But, the web evolved, didn't it? People started doing more complex things, logging in, shopping carts, personalized experiences.
Exactly.
How did that original stateless HTTP design begin to show its limitations? And what solutions emerged?
Precisely. As the web matured beyond just static documents, that statelessness became a significant challenge. If every request was a brand new interaction, how could a server remember you were logged in?
Right, or what was in your cart.
Or what was in your shopping cart, yeah. This led to the development of mechanisms like cookies.
Cookies. We hear about those all the time.
Yep. They allow a server to store small pieces of information on your browser to maintain context across these otherwise independent HTTP requests. It's a classic example of engineering trade-offs, really.
How so?
Design for simplicity first, then build layers on top to add complexity and functionality as needs evolve. But the real game changer, addressing an even more fundamental limitation, was the advent of HTTPS.
Okay, so HTTP was the trailblazer,
Right.
elegant in its simplicity, but then the internet started handling sensitive data, passwords, credit card numbers, personal information, all that stuff.
Very sensitive stuff.
That's where the S in HTTPS becomes not just important, but absolutely critical, isn't it?
Yeah.
What does that S truly add to the equation?
The S stands for secure, and it's transformative, really. HTTPS, or Hypertext Transfer Protocol Secure, layers a robust security protocol, specifically TLS, Transport Layer Security, on top of HTTP.
TLS. Okay.
When you see HTTPS, it signifies a secure connection with three core guarantees: confidentiality, integrity, and authentication.
Okay, let's break those down. Confidentiality.
Confidentiality means that the data exchanged between your browser and the server is encrypted. It's scrambled into an unreadable format, making it practically impossible for anyone to eavesdrop and understand it.
So it's like whispering instead of shouting across the room.
A very secure whisper, yeah. It's not just about keeping snoops out, though.
Right, you mentioned integrity too, so making sure what you send is what gets received.
Exactly, that's where integrity comes in. HTTPS ensures that the data being transmitted hasn't been tampered with or altered in transit.
Crucial.
And then there's authentication. This is also crucial. HTTPS verifies that you are indeed communicating with the legitimate website you intended to reach, not some malicious imposter.
How does it do that?
This is achieved through digital certificates, issued by trusted third-party organizations called certificate authorities, or CAs.
What?
When your browser connects to an HTTPS site, it checks this certificate. If it's valid and matches the site, it confirms the website's identity, preventing things like man-in-the-middle attacks where someone might try to spoof a legitimate site.
Ah, so that little lock icon in your browser isn't just a symbol of encryption. It's a badge of trust that confirms all three: confidentiality, integrity, and authentication.
Precisely. Nailed it.
It's like a digital passport for the website.
Exactly. That lock icon is your immediate visual cue that a secure, verified connection is established. Historically, some worried about the performance overhead of encryption, slowing things down.
I remember hearing that.
Yeah, but with modern computing power and optimized implementations, the impact on speed is negligible for most users. Actually, many browsers and search engines now prioritize HTTPS sites, and for good reason. Understanding that S in HTTPS provides significant peace of mind. It empowers you to actively look for it, especially when handling sensitive information. It's a fundamental best practice for your online security.
That deeper dive into HTTP's evolution and the multifaceted security of HTTPS is incredibly clarifying, really helps. We've decoded the language of the web, basically. Now, let's fast forward to the moment you're actually speaking that language, building a page right there on your desktop.
Okay.
Imagine you're creating a brand new web page, a personal project on your own computer. You're coding away, making edits. How do you actually see your work in progress displayed in your browser as you're developing it? Do you need to set up some complex server environment just for that initial spark of creation?
Not at all. And this is one of the most, empowering aspects of web development, especially for newcomers.
Really?
Yeah. To see a web page you're developing on your own computer, you simply save the file on your own computer and then load it in the browser. That's it.
Save and open.
Yep. There's no external web server needed for this initial local viewing. Your web browser, be it Chrome, Firefox, Safari, Edge, whatever.
Right.
It's perfectly capable of interpreting and rendering HTML, CSS, and JavaScript files directly from your local file system.
That sounds incredibly straightforward. So if I create a file called, say, index.html on my desktop containing all my code, I can literally just double-click that file.
Double-click it or drag it into the browser window or use File Open.
And it opens right up in my preferred browser, showing me exactly what I've built.
That's exactly right. The browser acts as an interpreter for those web languages. It reads the HTML, applies the CSS for styling, executes any JavaScript for interactivity, all without needing to fetch anything over a network.
Wow.
This immediate feedback loop is invaluable for developers. It lets you see your edits instantly and iterate quickly. I remember my first Hello World page, just seeing text appear in my browser from a local file. It's simple, but it's immensely empowering.
What strikes me about this local development process is just how low the barrier to entry is.
Okay.
You can literally start building a website with just a text editor and a browser. For someone just starting out, or even an experienced developer, what does that accessibility truly enable? And how do developer tools in our browsers enhance this process?
Well, it democratizes web creation, doesn't it?
Sure.
It means anyone with a computer can begin to understand how the web is built directly on their machine, fostering experimentation and learning.
That's huge.
As for enhancing the process, modern browsers come equipped with incredibly powerful developer tools. You usually open them with F12 or right-click and inspect.
Yes, the inspect element option.
Exactly. These are built-in suites that let you inspect the HTML structure, modify CSS styles live, and see the changes immediately, debug JavaScript code step by step, monitor network requests, and even simulate how your page looks on different screen sizes, like phones or tablets.
Right. Very useful.
When you're working locally, these tools are indispensable for fine-tuning your page, pinpointing errors, and really understanding how your code translates into what the user sees.
That's fantastic. So for a basic static web page,
Yeah.
you're pretty much set with just saving and opening.
Yeah.
But I imagine there comes a point where simple file opening isn't enough, right?
Yeah.
Especially if the web page needs to do something more dynamic, like, I don't know, fetch data from a database or run server-side code.
Absolutely. You've hit the nail on the head. While direct file opening is great for static content, HTML, CSS, maybe some basic JavaScript, many web applications require a server-side component.
Okay.
For those scenarios, developers often set up local development servers.
A server on my own machine.
Exactly. These are lightweight server applications that run on your own computer, mimicking a production web server environment. Things like Python's built-in server or Node.js-based servers like HTTP server, or more complete packages like XAMPP or MAMP.
Gotcha.
These allow your browser to request pages using http.localhost or http.127.0.0.1 instead of a file path.
And why is that important?
It becomes essential when you're working with things like client-side routing in frameworks like React or Vue, making API calls from your JavaScript, or dealing with server-rendered content. It more accurately replicates the actual network request process your page will undergo when it's live, but without needing to constantly deploy your code to a public server during development.
Ah, okay. So it bridges the gap between a purely local file and a fully deployed website.
Precisely. It's the next step up in local development complexity.
That's a crucial distinction.
Mm-hmm.
Okay, so we've gone from understanding the web's language, the HTTP and HTTPS protocols, to building locally.
Yeah.
Viewing directly or maybe with a local server.
Mm-hmm.
Now, you've put together your fantastic new web page. It looks polished, it functions perfectly on your computer, and you're ready to share it with the world.
The big moment.
Right. You want your friends, family, or even complete strangers to be able to access it from anywhere on the planet. What's the very next essential step you need to take to make that happen?
This is the moment your web server truly becomes indispensable. To make your web page globally accessible, you need to put the file on a web server.
The web server.
This is the essential bridge that transforms your local creation into a public, globally available resource.
Why is a dedicated web server so crucial for global access, though? I mean, my computer is connected to the internet. Why can't people just link directly to my machine once I'm online?
That's a great question, and it really gets to the heart of distributed computing and, well, practicality.
Okay.
While your home computer is online, it's typically not designed or optimized to be a public web server. First, it might not have a static, permanent IP address. Your internet provider might change it.
Ah. Right.
Second, it might go offline if you turn it off or lose connection. Third, and importantly, it simply wouldn't have the bandwidth or processing power to handle potentially thousands or millions of concurrent requests from across the globe if your site became popular.
It would probably crash.
Very likely, yes. A web server, on the other hand, is a dedicated, powerful, always-on computer, usually located in specialized data centers with high-speed connections. It runs specialized software like Apache or Nginx.
Heard of those.
Yeah, their sole purpose is to store your web page files, your HTML, CSS, JavaScript images, and serve them up efficiently to anyone who requests them through their browser using a specific URL. It makes it accessible to anyone on the internet with the right URL.
So it's like renting a public storefront for your digital creation, instead of trying to host it out of your living room where the lights might go out or the door might be locked.
That's a perfect analogy. Exactly.
And how do people find that storefront? That's where things like domain names and DNS come into play, right?
Spot on. And yes, finding that storefront relies on two fundamental internet services: domain names and DNS, domain name system.
Okay.
A web server has an IP address, that string of numbers like 172.2.2.160.142 or something, hard for humans to remember. A domain name, like example.com or google.com, is the human-readable address you actually type. DNS acts as the internet's phone book, basically.
The phone book, I like that.
It translates those memorable domain names into the numerical IP addresses that computers use to locate the correct web server across the vast network. So when you type google.com, DNS looks it up, finds the IP address, and your browser then knows exactly which server to connect to ask for the Google homepage.
That makes perfect sense.
Yeah.
So we've got the server, the storefront, and we've got the address system, domain names, and DNS. What are the common ways someone would actually go about putting their file on a web server today? What kind of hosting options are out there?
There's a whole spectrum of options, really, depending on your needs and technical comfort level.
Okay.
For simple static sites, just HTML, CSS, JavaScript services like GitHub Pages or Netlify are incredibly popular and often free for basic use.
How do they work?
You typically push your code to a Git repository, like on GitHub, and these platforms automatically build and deploy your site globally. Super easy.
Nice. What about more complex sites?
For more control, or for sites needing databases or server-side code, you might look at shared hosting. This is usually the cheapest option, where your site shares resources, CPU, RAM, on a single server with many other websites.
So it could be slower sometime?
Potentially, yeah, if other sites on the server get busy. It's cost-effective but has performance limitations. Then there's virtual private server, VPS hosting.
BPS.
Right, that gives you a dedicated slice of a server's resources and much more control over the software environment. It's a step up in performance and flexibility, but needs a bit more technical know-how.
And beyond that.
Then you get into dedicated servers, where you rent a whole physical machine or cloud hosting from providers like AWS, Google Cloud, or Microsoft Azure.
For cloud.
Yeah, cloud hosting offers immense scalability and flexibility. You can often pay only for the resources you actually consume and scale up or down easily. But it can also have a steeper learning curve. Each option has its trade-offs in terms of cost, performance, control, and the level of technical expertise required.
Makes sense. And beyond just where the files live, I've heard about content delivery networks or CDNs. How do these fit into the global accessibility picture? Are they a type of hosting?
Not exactly hosting, but they work hand in hand with it. CDNs are the unsung heroes of fast global web access. Think of them as a network of geographically distributed servers.
Distributed how?
Okay, let's say your main web server is in New York. If someone visits your site from Sydney, Australia, normally their request has to travel all the way across the world and back. That takes time latency.
Right.
A CDN will cache copies of your site's static content images, CSS, JavaScript on servers, located much closer to the user, maybe one in Sydney or nearby.
Ah, so it serves the content from nearby.
Exactly. So the user in Sydney gets the content much faster from the local CDN server. This dramatically reduces latency, speeds up page load time significantly, and improves overall reliability by distributing the load and providing redundancy. If one CDN server goes down, another can take over. So your primary web server hosts the master copy and handles dynamic stuff, and the CDN ensures the static parts are replicated and delivered from the closest possible point to the end user. It's pretty much critical for delivering a seamless experience on the modern global web.
Wow. So if we connect this to the bigger picture, this entire journey from a locally saved file on your desktop to being uploaded to a server, given an address via DNS, and then distributed globally via CDNs.
Mm-hmm.
That whole process is the bridge from a private project to a public resource. It's what transforms a simple .html file into a piece of the vast, interconnected World Wide Web.
Absolutely. Without the sophisticated infrastructure, the internet as we know it simply wouldn't exist. It underpins the entire distributed nature of the web, allowing information to reside in one place but be accessed quickly and securely from virtually anywhere on Earth.
It really highlights the immense coordination and complex systems working together constantly.
Yeah, every millisecond to deliver the seemingly instantaneous experience we often take for granted. It's truly the engine room of the digital age.
And that brings us, I think, towards the end of our deep dive today. We've journeyed through the foundational elements of the web, understanding that HTTP and HTTPS are the essential communication protocols the language browsers and servers speak, providing not just data transfer, but also critical security and integrity guarantees through HTTPS.
Right, the rules and the security layer.
We explore the accessible world of local web page development, how you can view your creations directly in your browser using just file open, and the role of developer tools and local servers for more complex work.
Making it easy to start.
And then we trace the critical step of uploading your creation to a web server, the storefront, complete with domain names, DNS, the various hosting options from shared to cloud, and finally, CDNs, all working in concert to make it a globally available high-performance resource ready to be discovered by anyone online.
You now possess, hopefully, a far clearer mental map for every time you type a web address or click a link. You're seeing beyond the letters to the intricate rules, the design philosophies, and the sophisticated systems at play. This knowledge empowers you, hopefully, to make more informed decisions about your online security, actively looking for that HTTPS lock icon, understanding its deeper implications, and to truly appreciate the incredible architecture behind the digital world you interact with daily.
So here's a final thought. Consider the intricate journey of every single web page you've ever visited. From being just a local file on someone's computer, meticulously crafted and checked, then uploaded to a powerful, always-on server, assigned a human-readable domain name, registered with DNS, maybe distributed globally via CDNs,
Often.
and finally, traveling across the internet, often securely encrypted with HTTPS, right to your screen in moments. What an incredible scale and coordination that implies.
It's mind-boggling when you stop to think about it.
And how might this profound understanding change the way you interact with information online? Perhaps making you a more discerning user, more aware of the security signals, or even inspiring you to contribute to this vast, interconnected world yourself from now on. Something to think about.